So number 1 is E0 for your galvanic cell. Hopefully you calculated that already. If you didn't, you know where to get the values for the half reactions to do it, correct? Okay, so number 2, you're generating a table for me, and actually a lot of the numbers below number 2 are showing me the work to get the data for that table. So, mass change for each electrode. How many electrodes do you have? 6. All right, and I would like to see a diagram of that setup somewhere. You can either label it in the lab itself or draw me one. You had 2 containers that have the same type of metal in them. So let's call this metal 1, and one of the electrodes there was metal 1. And the other electrodes were a different metal, and that metal was here. And they were connected. Remember how they were connected? Is light connected to light? No. Okay. So this one's going to be connected all the way over to here. Actually, that will be it. Where does this one go? Okay. Yeah, so let's just change this. Let's take this one. So that's the way. So that goes there, right? Yeah. So this purple goes to the green, okay? And that green goes where? Okay, so like so. Okay? And this is metal 1, this is metal 2, and you have all 3 of them labeled and identified, and hopefully some of them gained mass and some of them lost mass, right? Okay. So, you have the mass for each electrode, so you're going to have 6 rows or 6 columns. I'm not sure how you're going to set up the table. Either those, how do I get moles of mass? What do I need to do to get moles of mass? So for my table, I'm going to have mass of the metal. That's just change in mass, change in moles. How do I find that? Kenzie, how do I find moles? Mole from mass. Okay, so that's the easy one. I divide mass by formula mass, atomic mass, and I get the moles. I'm looking for the number of coulombs. How do I get that? How do I get from moles? This is changing moles of the metal. How do I get from here to coulombs? What do I? Can I go directly? I do feel like that. Let's think about this. I get moles of metal. How did I get my metal? How is that formed? Or how is that removed? What did I have to do to get metals to atoms? Here.
Run a current through it.
And? What is a current?
Moving electrons.
Moving electrons. So, I've got to get electrons involved here somehow, right?
Sure.
Charge. Well, I'm going to use the charge of electrons, not just yet. I have moles of metal. What might I want to find next
Moles
on
of
my
electrons.
moles of electrons? So I'm going to take moles of metal. How do I get from moles of metal to moles of electrons? Let's pick zinc here. How do I get from moles of zinc to moles of electrons?
Zinc is a +2 ion, right?
Okay.
So it takes 2 electrons to like put it back to a neutral zinc atom.
Okay, so you're going to take the moles of electrons, moles of metal, and do what with it?
Double. Yes.
So multiply it by?
2.
Okay, so the number, so it's charged basically, right?
Yeah.
So that's going to give me moles of electrons. Yes? You good so far?
Yeah.
All right, it's the same. How do I get from moles of electrons to coulombs?
Multiply by the charge of 1 electron.
Not by the charge of 1 electron.
By the charge of mole of
The charge of a mole of electrons. What do we call that? Charge of 1 mole of electrons. Okay. A Faraday. So I'm going to multiply this by a Faraday. Who remembers what a Faraday is?
96,500.
485.
485.
Coulombs per electromole of electrons. Okay, so that's going to give me my number of coulombs, right? Okay, so that's the third part of my chart. And then theoretical current. How do I get to current if I know the number of moles of coulombs? What is current? Definition.
Yeah.
One equation.
Sorry.
Like I equals C over S.
It's something
Yeah.
over second.
I is
Yeah.
current equals, what's C stand for?
Coulombs.
Coulombs.
Over
So it's charge in terms of coulombs over time. Do I know how long I ran my system?
Yeah.
24 hours.
Well,
Ish.
ish. So you got to take that time and get it into seconds. So you got the coulombs you just figured out, and here's how you take that charge. So this is going to be coulombs divided by time in seconds, and that's your theoretical current. All right?
You just figured it out real quick.
Yes. So it's going to be a relatively sizable chart. All right, so number 3, you're showing the calculations to get all those, at least one. And 4 and 5 are basically the same question. If you don't have copper, then you're going to be answering one of the questions for zinc and the other question for aluminum. If you've got copper, then that would be number 4, and then 5 would be either zinc or aluminum. Am I making sense? Okay. So how many moles of copper were dissolved? Well, you've got that in your table. Okay, you don't have to show the calculations because you've gotten it. What should be true? What metal do you want the green ones to be, Daddy? Let them be zinc. Wonderful. Okay, so that means this green thing is zinc over here. What's your purple one?
Copper.
Okay, you had copper? Okay, so that's copper. So, for this particular reaction and then 2 other different reactions, you got to make it appropriate to yours. Which oxidizes and which reduces, Maddie? The copper or the zinc oxidizes? Look at your E0 if you don't remember.
Doesn't zinc oxide.
Zinc oxidizes. Okay, so if the zinc oxidizes, are the electrons going to be leaving here or are the electrons going to be coming in there?
Leaving.
From the zinc.
Yeah.
Okay, so the electrons go that way, which means the electrons are going to be coming into the copper. Would you agree?
Yeah.
Okay, so let's look over here. So the electrons are leaving. What should be happening to the mass of this particular electrode? It should be increasing. How about the mass of this electrode?
Isn't it increasing as well?
Well, if this mass is increasing, that means that I'm pulling copper ions out of solution
Yeah.
and depositing them there. So the negative ions are going over there, right? So I gotta have electrons continuing. So if electrons are going in here, what do they have to be doing here to finish my circuit? Okay, so electrons have to be leaving here. So if electrons are leaving here, what should be happening is the mass of that electrode? It should be decreasing, okay? And over here, what about the zinc electrode? What should its mass be?
Increasing.
And the other zinc electrode?
Decreasing.
Okay. And now the electrons leave and they come over to here, that copper electrode should be, since it's increasing in mass, so the zinc electrode should be dissolving. Okay. So on your diagram, hopefully you know which electrode was hooked up to which.